In this video, we show how to generate an executable counterexample using SeaHorn. In this program on the left, we set x to a non-deterministic integer, and then we assume that x is between 1 and 100. Then we compute the square of x, and we state that there is an error if the square of x is greater than x. In this case, it's not difficult to see if there is an error, so we would like to ask SeaHorn for an executable counterexample. So we can do this by typing the following command. So here SeaHorn returns false, which means that there is a counterexample, and it generates a file. So the first thing that we do is to actually double check that this file is executable. And now we are ready to run it. So what we should see here is a message that says that verifier error has been executed. However, we don't see any message, so the next thing that we can do is to run LDB on this executable. So we set a breakpoint at main, and we just run the program. So we can see that verifier error wasn't executed, and we just returned from the program. So we can actually also ask LDB for the values of x and y. And we see that x is equal to y, and in this particular case is equal to 1. The reason why is because the model checker doesn't model nonlinear multiplication in a precise way. So what we can do is basically to ask SeaHorn, and in particular the directed symbolic execution component, to try to model the counterexample provided by the model checker, but in this case using a bit precise semantics. So what we do is to add the option bit precise. Here I would like to emphasize that this option is not passed to the model checker, since the model checker doesn't reason about nonlinear or bit precise semantics, but instead is passed to the directed symbolic execution component. So we see that it's another file that has been generated, and now we try to execute it. And we can see now that the message verifier error was executed is printed. So we can now again to run LDB on this executable and see which are the values for x and y. So now we can see that verifier error is executed, and we can see the values for x and for y. So here we can see that y is actually the square of x, which in this case is 68. So with this, we have reached the end of this video.